So chapter 12 is an introduction to data warehouse and BI system. And this particular chapter is actually related to your project in many ways. There's a lot of concept and the job we are doing are actually the concept introduced in this particular chapter. I'll move this away so we have a better screen here. So that is they talk about something about big data, but the basic concept is this. And this one is the picture we see actually all the way from chapter 1. So chapter 1 has the same picture. Now chapter 12, to wrap up the semester, we have another picture here. So typically this is how the textbook is organized. At the beginning, we are looking at on the right-hand side how to manage data in a operational database by building data, by rearrange data, by normalize data into a database so that database can be used for transaction process. And in later chapter, we start talking about this SQL language to manipulate database, redesign the database. The purpose of redesign database is to create the database that is more suitable for the BI system. So if you are working on the project that we have this semester, the Tyson frozen food project, and many of you already know that there are two databases on the Sam's Club, well not Sam's Club, sorry, University of Arkansas virtual environment, and one of them is the data warehouse. The other one is the operational database. They have not the same copy of database data, but the data warehouse version is actually copied from that. And the data warehouse version has something what we call a star schema, and that is introduced in this particular chapter here. So the overall idea is we need to have a very good understanding of how your system is arranged. And typically in today's environment, we have to access to both. It depends on what you're trying to do. Say for example, many of us has experience of looking at your credit card statement online. Go to your credit card company, you log in, you can check your credit card company information, right? And you can take a look at your statement and the transaction you've been handling. Those data usually are coming out of this operational database. Right? But on the other hand, many database or the credit card company also give you the option of doing analyzing your spending pattern. They give you a pie chart that says, okay, 30% of your money is going to rent, 50% going to food, and that sort of thing, right? Or you 104% over your budget, and those information are coming from both of their historical called data warehouse as well as your operational database. So this is a typical environment. So what you are learning in the database environment, well, not database, business intelligence environment, is not the database, right? The way that our course is related to the business intelligence or data mining is that you know how to prepare the data on the orange or the yellow side, orange side, right hand side of the picture. But when you go to the data mining class, you have to learn the tool that be able to perform data mining, reporting, even though we have some reporting tool here as well. And so that you need to know how to access the data through the interface, and that is what we contribute here. And of course, the material cover in terms of ETL process in this course is very primitive. We kind of using the text format, and more sophisticated formats, say for example using JSON format or XML is more like what we do in modern environment. Right? In Python, like I said, usually use JSON. And JSON, I think JSON structure was introduced in one of our tutorial here. Right, so that's the typical thing we try to do here. And the process, of course, is ETL process. Again, this is a duplicate picture we get from chapter 1. Right? So the blue block here says about ETL system. In modern day, I mean even today, most of us are still using the method we are using in this class, manual method to copy and paste and to but at least now you know you can use query to simplify or arrange the data first before you actually extract them to an Excel spreadsheet or data file. Now in Oracle environment, there is a certain utility called data pump. Data pump can do perform the data extraction much faster, but you have to learn how to. Data pump itself can pump the entire database, but you want to learn how to control it by writing stored procedure to control that data pump, and that is not covered in our class, but that is the feature is there. You can do a much faster data movement in between database using data pump. Every company has their own utility to do so, and this makes the job a high-paid job because a good data scientist, he or she will know all different kinds of tools and to access because the environment is always very complicated. We have Oracle, we have Microsoft, we have IBM, we have Sybase, we have all these companies out there. Every one of them has a different tool to do a job. So you have to be familiar with all the tools and be able to write procedure to semi-automate the process to do a good job. So, but typically, if you're good with Excel, you can do most of the job already in production environment. Excel, even though it sounds like very low tech, but it is extremely important tool for us to learn in the database environment. Right. So the chapter is very similar to the chapter 11 that they talk about a lot of this terminology of different BI tool. And it becomes important when you go into this place called the star schema, and they've created several different concepts, right? In a nutshell, and to simplify this concept is it all the way back into chapter 3 and 4 to chapter 5. We were talking about this read-only database or denormalized database, and this is your denormalized database. So basically, the fact table is, if you recall that in our learning of ER diagram, ER model, I emphasize on a pattern called the line item pattern. And the line item pattern looks something like this. All right, so looks something like this. And so we have a line item, and the middle part of the line item is, all right, I should change the words here. I hope that if I repeat information, you kind of recall what I said about this pattern-driven design, and that is extremely important. So when you look at the data model like this, and in a production environment, you will be encountered in university too. You look at university. And all these tables are out there, and you can reverse engineer, and somebody may give you a documentation about what table. And you need to learn how to focus your, you have to focus on a particular table that you know they contain the most critical information. Right? And this critical information is always, so I'll give you like 5 seconds to think about. If you look at all these, which one is the most important one? Right? The most important one is this one called invoice. Now, why invoice is the most important one in this data structure? In this many table here. So if you go into the Tyson Food database, try to look something more like an invoice there, and you will be able to pinpoint the center of the database. And because the invoice is a transaction, so every time you have a transaction, you have an invoice. And we spent some time talking about transaction in previous section for this purpose. So invoice is a transaction, and it's described as, in a data warehouse term, as something what we call fact. Facts are transaction, but it's a transaction including all the important fact information. So when you try to generate this fact table from this environment, you have to take the invoice and join the table that is relevant to the invoice. In this case, the information relevant to the invoice are customer and product. So you have to join customer and product together with the invoice. These 4 tables together become your fact table, right? So that becomes your fact table. And so that is the concept of fact table. Now, what other dimensional table mean? Dimension table, using our database concept, the best way to describe it, dimension table is like your index. Index is a tool that in database we generate to speed up the performance of searching. So if you want to search a database, how do you search? Of course, you can search by any keywords, by any column. But in database environment, in theory, well, actually, not in theory, in practice, you can do that as well. You can search in every column in your table and find the information you want. But the performance is different, right? If you do not generate the index, the performance without index will be much slower than the table with index, right? So if you don't think about performance, then they are all about the same. But if you think about performance, providing the index is speed up the machine process much faster. The algorithm is much simpler. So this is the concept of star schema, that they put the index as dimensional table. So build a data structure like this. So basically what they are trying to tell you is, I'm going to be building this data warehouse about this product sale invoice information. This information can be searched most early through customer, through product, or through time. Right? So these are the 3 dimensions I provide to you so you can search faster. In the earlier time, the ultimate goal of data warehouse is to increase the performance of data warehouse fast, because you're handling big data. If you cannot issue a query there and it run like 3 days or 5 days, too slow. You want this to come out in less than 5 minutes or 1 minute, the best. So that you have to create this data structure, and this is a denormalized data structure. So based on that concept, and this is actually a Microsoft Access environment, and they will tell you that, how they are related in CAR. But once you put them into the star schema, it's much faster to search. So these 2 data model contain the same information for the customer, invoice, line item, and product, and they have a different structure. And how do you move from here to there is the topic that we discussed in the database redesign. So you have to create new table here, and you have to select the data and join the table, and the output will be inserted into this new table. So that process using query is how you build data warehouse. So and there's still some job out there ask people to build data warehouse all the time. So your job will be very good at the SQL, be able to insert, create table, insert and join table, and insert into new table. So that's something that we didn't actually do in our class, but it was actually a few examples in the chapter showing you how to select and insert using query when we introduced data definition language and data manipulation language back then. Right, so those are some examples that in the class. And so that is actually the most important concept to learn, that you need to, now you know that this is something called a star schema. And when you move into the data warehouse class, if you choose to take that elective class in the program, you also learn another one called the snowflake schema. Very similar to star schema, but snowflake is a little bit more complicated. It's more distributed structure. This is actually a very centralized structure, because you see that the transaction be converted into a fact table in the middle, so it's kind of spread out. Snowflake, you have a little multiple center in multiple stars, so to speak, but it creates a more flexible search mechanism, but it actually slows down the mechanism. So that is actually what chapter 12 is trying to tell you. And at the end of the chapter, they also introduced the concept of the slice and dice using dimension, and the term dimension will become very important term to use in data warehouse world. The dimension is uh, the index you can search, and measurement will be the value you can measure. So measurement and dimension will be the two things that we use a lot in data warehouse. There is an example of called is actually very interesting example called the RFN analysis on your textbook. This one, and actually there was one semester when I first teach using this textbook about 10 years ago. I actually give the student the RFN program. Actually, you can download the program, the store procedure, from the textbook website, and build a report using the RFN. Very interesting. Just very quickly, so if your future job you have similar similar needs. If you recall that you heard about us talking about this, this is a very typical customer segmentation algorithm, the AI algorithm that used to target our customer. This is called the RFM analysis, right? R stands for recency, F frequency, and money, amount of money. So using these three indicator or so-called measurement, we try to figure out who are the most important customer, and also classify customer into different group, profile them, so give them different promotion. That sounds familiar? Doesn't sound like what Amazon is trying to do to you? This is the foundation, right? So this is the foundation AI algorithm try to teach you how to classify customer into different group. In this case, based on three different criteria, and they generate a value to say, okay, this is the most important customer. If you want to spend your promotional money, put in those customers where they can see it. Right? So that's what's going on there. So that's the whole chapter. And even though this is a 2019 version, it still does not have the newest information. The newer version of the data warehouse are business intelligence system, including more AI. But that part is now not our concern in the database class anymore. So we will stop our discussion here at this level that we know what database can do. And just for as a conclusion, because this is the last chapter of our class, if you have a goal to become a data analyst or a data scientist as a job, a career goal, there are two recommendations I have. Right? Of course, one recommendation is that you got to be very good with spreadsheet, Excel, right? Because a lot of these data management are still done in Excel, so ETL done in Excel. The second recommendation is do not be overwhelmed by all these new things coming out, Python or R language or SAS. You only need to have one tool. And database is actually a tool that can do a lot. If you go to the Oracle or Microsoft website, almost everything you can do in R, you can do in Oracle database environment. And actually, the Oracle environment has a native R engine in there, so you can issue Oracle function to run R within Oracle. So you become an expert in one system. That's good enough to land you a job. You don't need to know everything. You don't need to know Python. You only need to know SQL very well and know one system. Not it's Oracle or Microsoft SQL Server. One of these two products are very well, then you can land a very nice data analyst job. And a lot of this AI program procedure can be written in this environment as well. Right. So that's my two recommendations for those of you who are aspire to become a data scientist or data analyst. Those are two different things. Data scientist is more detailed, theory-driven building. Say developing vaccine will need a data scientist. Data analyst is more in the business environment, do more descriptive analysis, and data scientists do more predictive and explanatory sort of analysis. So two different models. So when we build chart and report, it's more descriptive than prescriptive or predictive. Okay, so that's the end of the chapter, and I can wrap up the lecture here today.